Dear learners, Namaste. Myself Dr. Shailendra Kumar Sharma. Currently I am teaching in a Government Model Degree College, Saharanpur, Uttar Pradesh. Topic of this session is chi-square. So during this session we will understand the nature and theoretical framework of frequently used this statistical test. Specifically, as session will proceed, we will learn concept of chi-square, properties of chi-square, assumptions of chi-square, applications of chi-square and limitations of chi-square. Sometimes in psychology discipline or in the field of behavioral sciences, our nature of variables are categorical and we get data in terms of frequencies. Problems of such variables in data are like, are males more likely to be smokers than females? We may take another example like, is there any relationship between gender and smoking behavior? So, looking to the nature of variables in data, we employ a very special and frequently used statistical tool, that is chi-square. As we are going to understand thoroughly about this test in current session. And during this session, we will try to understand, as I said earlier, the concept of chi-square, properties of chi-square, assumptions of chi-square, applications of chi-square test and limitations of this statistical tool. So let us go through the introduction part of this statistical tool. This test was originally developed by eminent scholar of statistics whose name was Karl Pearson, and he developed this very important test in 1900, and this test is sometimes called the Pearson chi-square. And the Greek letter chi-square is used to denote this non-parametric test. Non-parametric tests are sometimes called distribution-free test. This test does not assume anything about the underlying distribution, whereas as we know in parametric test, such test makes assumptions about population parameters. For example, the mean or standard deviation. Put it simply, when the word non-parametric is used in stats, it does not quite mean that you know nothing about the population. It usually means that you know the population data does not have a normal distribution. In other words, no constant of a population is used in non-parametric test. Data do not follow any specific distribution and no assumptions are made in this test. For example, to classify good, better and best, we just allocate arbitrary numbers or marks to each category. This statistical test follows a specific distribution known as chi-square distribution. So let us understand what is chi-square. As Garrett defines chi-square in terms of the difference between observed and expected frequencies are squared and divided by the expected number in each case and sum of these quotients. Guilford states chi-square is the sum of ratio. Any number can be summed. Each ratio is that between a square discrepancy of difference and an expected frequency. According to Kurtz and Mayo, 1980, chi-square is often used to determine whether a set of observed frequencies is such that might well have arisen as a result of chance fluctuations from the frequencies that would be expected on the basis of a theory of any kind. In other words, a Pearson's chi-square test is a statistical test for categorical data. It is used to determine whether your data are significantly different from what you expected. On the basis of above definitions, it can be said that discrepancy between observed and expected frequencies is expressed in terms of a statistics named chi-square. So let us have a look about the major properties of chi-square test. First is, this test is based on frequencies and not on the parameters like mean and standard deviation. So this is the first major property of chi-square test. Second property is important non-parametric test. This is a kind of important non-parametric test. As I said earlier, this is a frequently used statistical tool. No need of parameter values and relatively less mathematical details are involved in this particular test. The test is used for testing the hypothesis and is not useful for estimation. This is the another major property of chi-square test. Next property is, as the degree of freedom increase, the chi-square curve approaches a normal distribution. And last major property of this chi-square test is, this test can also be applied to a complex contingency table with numerous classes. A contingency table contains a matrix format and displays multiple frequency distribution of the variables. Now let us understand in detail what is contingency table. In contingency table, one variable and each of its categories are listed vertically and the other variable and each of its categories are listed horizontally. Let us go through this particular table. As you can see here, at vertical level gender is there, and at horizontal level participants have expressed their opinion in terms of three categories: favorable, neutral, unfavorable, and frequencies are given in each cells. So this is a kind of contingency table which includes two variables, two categorical variables. So contingency table, also known as two-way table, are basically grids in which chi-square data is organized and displayed. And what is the importance of making this kind of table? Such kind of tables provide a basic picture of the interrelation between two variables and can help find interactions between them. So this is most important in basically computation of chi-square table. We make contingency table for our ease while calculating chi-square value. So now we are proceeding ahead, and next topic of this chi-square test is assumptions of chi-square test. So let us understand what are different assumptions of this statistical tool. First assumption is, data contains frequencies. In chi-square test, data should be based on frequencies, and you know, in statistics the frequency of an event is the number of times the observation occurred or recorded in an experiment or an study, and these frequencies are often depicted graphically or in tabular form. The chi-square, next assumption is, the chi-square is applied when there is quantitative data. Quantitative data is the value of data in the form of counts or numbers, as we know, where each data set has a unique numerical value. This data is any quantifiable information that researchers can use for mathematical calculations and statistical analysis to make real life decisions based on these mathematical derivations. Next assumption of chi-square is, the observations should be independent in nature. So, what does it mean by independent? It means measurements for each sample subject are in no way influenced by or related to measurements of other subjects. Next assumption of chi-square test is the sample drawn from the population about which inference is to be made should be random. A random sample is one in which each sampling unit has an equal chance of being chosen in the sample. Consequently, sample becomes representative in nature. Next assumption of chi-square test is if there are only two cells, the expected frequencies in each cell should be 5 or more, because for observation less than 5, the value of chi-square shall be overestimated, resulting in the rejection of the null hypothesis. For more than two cells, next assumption is for more than two cells, no more than 20% of the expected values may be lesser than 5 and no expected value may be lesser than 1. If more than 20% of the cells have expected frequencies less than 5, then chi-square should not be applied. Now, we are going ahead towards next assumption of chi-square test. Next assumption is a sample with a sufficiently large size is assumed in chi-square test. If sample size is small, then chi-square will yield an accurate inference. And you know, inference matters in such kind of inferential statistical tools. In general, larger the sample size, the less affected by chance is observed distribution, and thus the more reliable the test of hypothesis. Next assumption is the data should be expressed in original units rather than in percentage or ratio form. Such precaution helps in comparison of attributes of interest. So, these are different assumptions of chi-square test. We are moving ahead, and next topic is applications of chi-square test. Applications. So, these are three major applications of chi-square test, and somewhere in stats books these are the different types of chi-square test. So, what are the different types, or we may say the applications of chi-square test? First is goodness of fit. Goodness of fit, I will explain later in detail. And second is test of independence. And third application of chi-square is test of homogeneity. So, these are three main applications of chi-square test. So, let us understand in detail about these applications of chi-square test. First application, or the first type of chi-square test. First is goodness of fit. In statistical hypothesis testing, the chi-square goodness of fit test determines whether a variable is likely to come from a given distribution or not. In other words, goodness of fit test determine how well sample data fit what is expected of a population. So, we must have a set of data values and the idea of distribution of this data. We can use this test when we have value counts for categorical variable. This test demonstrates a way of deciding if the data values have a good enough fit for our idea or if it is a representative sample data of the entire population. Put it simply, it hypothesizes whether a sample is skewed or it represents the data you would expect to find in the actual population. In goodness of it, one thing we have to remember is there is only one or single categorical variable. We have to remember it. For example, suppose we have bags of balls with 5 different colors in each bag. The given condition is that the bag should contain an equal number of balls of each color. The idea we would like to test here is that the proportions of 5 colors of balls in each bag must be exact. So, this is the first application of chi-square test. Now, come to the second application of chi-square test. Second application is test of independence. The chi-square test of independence is a derivable, also known as inferential, a statistical test which examines whether the two sets of variables are likely to be related with each other or not. This test is used when we have counts of values for two nominal or categorical variables and is considered as non-parametric test. A relatively large sample size and independence of observations are the required criteria for conducting this test. For example, suppose in a movie theater we made a list of movie genres. So, let us consider this as the first variable. Second variable is whether or not the people who came to watch those genres of movies have bought snacks at the theater. So, here the null hypothesis is that genre of the film and whether people bought snacks or not are unrelatable. And if this is true, the movie genres don't impact snack sales. So, this is the meaning of test of independence, and this is the second application of chi-square test. Now, I am moving ahead and I am going towards the third application of chi-square test, and this is the test of homogeneity. So, let us have a look about test of homogeneity. The test of homogeneity is useful in a case when we are interested in verifying whether several populations are homogeneous with respect to some characteristics of interest. For example, a movie producer is bringing out a new movie in order to develop an advertising strategy, and he or she wants to determine whether the movie will appeal most to a particular age group or whether it will appeal equally to all age groups. So, we formulate the null hypothesis that the opinion of all age groups is same about the new movie. Hence, the test of homogeneity is useful in testing a null hypothesis, that is, several populations are homogeneous with respect to a character. So, this test is different from the test of independence on account of the following regions. And what are these regions? How it differs from test of independence? First region is, instead of knowing whether two attributes are independent or not, we may like to know whether different samples come from the same population. So, this is the first region we have. And second reason is, instead of taking only one sample for this test, two or more independent samples are drawn from each population. So, this is the second region, and based on this second region it differs from test of independence. And third is, to apply this test, first a random sample is drawn from each population, and then in each sample the proportion falling in each category is determined. The sample data so obtained is arranged in contingency table. The procedure for testing of hypothesis is same as for the test of independence. Now, we are moving ahead and let us understand the precautions about using the chi-square test. A sample size, the first precaution is a sample size should be enough. If the expected frequencies are too small, the value of chi-square gets overestimated. To overcome this problem, we must ensure that the observed frequencies in any cell of the contingency table should not be less than 5. Second precaution of chi-square test is, when the calculated value of chi-square turns out to be more than the critical or theoretical value at a predetermined level of significance, we reject the null hypothesis. In contrast, when the chi-square value is less than critical theoretical value, the null hypothesis is not rejected. However, when the chi-square value turns out to be 0, we have to be extremely careful to confirm that there is no difference between the observed and expected frequencies. Such a situation sometimes arises on account of faulty method used in collection of data. Now, let us understand the limitations of chi-square. First limitation is, chi-square, like any analysis, has is that all participants measured must be independent, meaning that an individual cannot fit in more than one category, and if a participant can fit into two categories, a chi-square analysis is not appropriate. Second limitation is, it can only tell us whether two variables are related to one another. It does not necessarily imply that one variable has any causal effect on the other. In order to establish causality, a more detailed analysis should be required. Third limitation is, chi-square is sensitive to small frequencies in cells of tables. Generally, when the expected value in a cell of a table is less than 5, chi-square can lead to errors in calculations. Now, we are coming towards the final part, and that is conclusion. It can be concluded that chi-square test is the most frequently used non-parametric statistical tool. Non-parametric techniques are used when a researcher works with ordinal or nominal data, or with a small number of cases representing a highly asymmetrical underlying distribution. The chi-square test deals with data that are given in frequencies or categories. Second, the chi-square test is used for mainly two broader purposes. First is, it is used for the test of goodness of fit, and secondly as a test of independence. As a test of goodness of fit, chi-square tells us whether the frequencies observed among the categories of a variable are tested to determine whether it differ from a set of expected hypothetical frequencies. As a test of independence, chi-square is usually applied for testing the relationship between the two variables in two ways. First, by testing the null hypothesis of independence, and second, by computing the value of contingency coefficient, a measurement of relationship existing between the two variables. When we have less than 5 observed frequencies in any cell, then we use the AIDS correction. Thank you so much.